Welcome back to The Explainer. Today we're going on a seriously wild ride. We're taking a journey from our most primitive, primal survival senses all the way up to the literal, physical neuroscience of willpower. It's a fascinating connection, so let's just jump right in. Okay, let's kick things off with a question that completely shatters a very common biological myth. Can a human track a buried scent just as well as a bloodhound? Now, we usually assume we're completely inferior in this department, right? But is that actually true? Get this. The revelation here is just absolutely amazing. Our biological hardware is actually elite. The raw pixel density of our sense of smell is essentially the exact same as a bloodhound's. There's no way, right? But it's true. Hounds just mechanize their sniffing better. They have these physical notches in their noses to create air vortices, and they sniff way more frequently, getting like 10 to 20 times the exposure to an odor plume. So they don't necessarily have better equipment, they just use it differently. To actually prove this, researchers at UC Berkeley ran this incredible experiment. They literally took human subjects out into a field, blindfolded them, put thick, heavy gloves on them to block vision and touch, and basically told them to follow their noses. And amazingly, these subjects successfully tracked a trail of chocolate scent buried 7 inches underground. They were zigzagging through the grass exactly like scent hounds out in a field. It is a wildly funny mental image for sure, but it perfectly illustrates that we possess this immense, untapped capacity, just waiting to be utilized. Now, you might be wondering, if we have these literal super senses, why are we just hearing about this now? Well, to understand why, look at this striking exchange. Legendary music producer Rick Rubin recently asked the chair of neurosurgery at a major medical school a really simple question about the accuracy of standard medical textbooks. The answer? 50%. Yeah, half. That means half of the information in currently used medical textbooks is completely outdated. Modern science is constantly rewriting what we know about the human body, the brain, and our physical limits. The scientific literature updates incredibly fast, but that new understanding takes a really long time to filter down into standard education. All right, moving on to genetics and senses, the canine blueprint. Let's look at our four-legged friends to see how biology trades certain advantages based on environmental needs. This comparison perfectly grounds our understanding of biology. Take the original wolf lineage, for example. Dogs like shepherds or collies kept those long snouts, maximizing that deep olfactory chamber to hunt via sight and scent. But over centuries, humans bred mastiff lineages like bulldogs or pugs to be snub-nosed. By trading away that long snout, they gained incredible jaw leverage and massively reduced the pain receptors in their faces. It really shows how physical hardware is literally molded to prioritize either sensory awareness or pain tolerance. Next up, the reflexive brain, adrenaline, and survival. Let's look at how a simple scent triggers an autonomous survival reflex. Because smell isn't just about finding chocolate, right? It's our most ancient, hardwired alarm system. This sequence lays out exactly why you see massive powerlifters sniffing intense-smelling salts before a heavy lift. When you inhale a highly aversive scent, it completely bypasses the slower thinking parts of your brain. It hits the accessory olfactory bulb, takes a fast-track wire straight to the amygdala, which is your threat detection center, and instantly floods your system with adrenaline. It's a hardwired physiological hack that forces your body to mask pain and prepare for explosive physical action. So whether you call it adrenaline or epinephrine, the physiological purpose is exactly the same. It's a neuromodulator released simultaneously by your adrenal glands and a sort of sprinkler system in your brain called the locus coeruleus. Its sole purpose? Motion. It gets you ready to move right now. You know, despite our massive, super sophisticated cerebral cortex, our ancient brain still filters literally every single piece of information into 3 really simple physical reactions. Yum, which means move forward. Yuck, retreat. Or meh, just pause and evaluate. At our core, we are wired for immediate physical action based on the sensory data we take in. Which brings us to the anatomy of willpower. What happens when our primal brain says, yuck, I want to retreat, but we force ourselves to move forward anyway? Well, I want to introduce you to the anterior mid-cingulate cortex, or we can just call it the AMCC. We can essentially think of this as the biological epicenter of human willpower. We usually think of willpower as this abstract, fluffy, psychological trait, but it's really not. It is a measurable physical structure in your brain, and its size directly corresponds to your ability to do hard things. And here is the absolute golden rule of the AMCC. It only grows when you push through tasks you actively do not want to do. If you love doing heavy deadlifts, doing more deadlifts is great for your muscles, sure, but your AMC, totally stagnant. It demands high internal friction. We're talking about resisting the urge to quit a diet or forcing yourself into a freezing cold plunge when you'd rather be anywhere else. Doing what you love leaves this area completely unchanged. So, why does all this matter? Because building this willpower muscle literally acts as a neuroprotective shield. Researchers have studied this group known as superagers, older folks who experience a dramatically slower slope of age-related cognitive decline. And the universal defining biological trait among these superagers is a significantly larger AMCC. They hold on to their memory and sharpness not just by doing crossword puzzles, but by habitually leaning into difficult, unwanted physical and mental challenges throughout their entire lives. Finally, let's look at movement for the mind. Let's synthesize everything we've talked about with the ultimate actionable tool, physical movement. Looking at this table, we see it as no coincidence that historical cognitive giants also built tremendous physical strength to fuel their brains. Santiago Ramon y Cajal, the Nobel laureate who literally discovered the neural synapse, was famously a bodybuilder. He carried around an iron umbrella and lifted heavy weights. Oliver Sacks, the renowned neurologist, was an absolute physical beast who held a state powerlifting record with a 600-pound squat. Intense physical exertion is directly tied to intellectual longevity. When we engage in intense movement, we're basically spiking a highly specific chemical cocktail in our brains. Dopamine gives us the motivation, epinephrine triggers ultra-high alertness, and serotonin opens the pathways. Together, these precise chemicals create the exact environment an adult brain requires to achieve neuroplasticity, to physically rewire itself, learn new things, and stave off cognitive decline. So, knowing that willpower isn't just some concept, but a literal physical structure you can consciously build, I'll leave you with this final thought for today. Knowing the immense biological potential you possess, from your primal senses down to your cellular chemistry, what difficult task will you actively lean into today? Choose the friction, build that willpower muscle, and unlock your potential. Thanks for hanging out with us, and keep pushing.